Welcome, everyone. We're right at the hour, so I think we'll go ahead and get started. You have joined the webinar, Wildfire is a Joint Venture Enterprise, researchers, forecasters, and fire managers working together to improve public and wildland firefighter safety. My name is Kat Compton, and I'm a Presidential Management Fellow working with NOAA's Regional Integrated Sciences and Assessments, or RISA program within the Climate Program Office. And I'd like to provide a little bit of background about the RISA program, but before I do, just a little bit of quick housekeeping. We are recording this webinar, and we'll send out a link to all of you once it's posted up on our website. Also, please feel free to submit a question or a comment at any point during the presentation using the chat box provided. And we've reserved some time at the end of the hour for questions and discussion, and we'll get to as many questions as we can. Okay, next slide, please, Tamara. The work you're going to hear about today on spot weather forecasting provides what I think is a really excellent illustration of the goal of the RISA program, which is to sit at the intersection of research and stakeholder engagement focused on regionally identified weather and climate-related priorities. RISA teams create credible and innovative physical and social science research products that meet the needs of decision makers and help build and expand the nation's capacity to prepare for and adapt to climate variability and change. Next slide. RISA teams have worked with a wide range of stakeholders and decision makers over the last 2 decades of the program, and here's a list of just some examples to give you an idea of the breadth of the RISA work. What we've learned, and what I think today's presentation will make abundantly clear, is that high quality, credible, and usable science requires a deep understanding of the decision context and a trusted network for the flow of credible information and feedback. And I think these are real strengths of the RISA teams and crucial components of their success. Next slide. Right now, there are 11 RISA teams in regions all across the country, and each focuses their research portfolio on regionally identified weather and climate-related priorities. So it should come as no surprise to us then that the California-Nevada Application Program, or CNAP, has built a network where researchers, forecasters, and fire managers can come together to share information around fire safety, including what we'll hear about today, the real and perceived accuracy of local spot weather forecasts. I want to take a quick second and turn the floor over to our colleagues at the National Weather Service, Robin Heffernan and Heath Hockenberry, and then I can introduce today's speakers. So over to you, Heath and Robin.
All right, this is Heath Hockenberry. Just wanted to give you a background of the National Weather Service requirements for spot forecasts and their verification as well. I work within the Analyze, Forecast, and Support Office under Michelle Hawkins and Andy Stern, and we drive the requirements. We are influential in the development of the National Weather Service Annual Operating Plan. And so our requirements do get up to and validated by the National Weather Service Mission Delivery Council. The Mission Delivery Council took the time last summer to validate some high-level requirements that are basically linked back the whole way to legislative documents, service assessments, the NAPA report, things that our AA considers of high value in determining and documenting requirements. And I believe the spot forecast does fit within these 3 categories that have been validated as MDC requirements. And you can see them bulleted here: continuously monitored fire intelligence for hazard messaging, forecast monitoring capability, very specifically for spot forecasts. That wording is in the high-level requirements, and effective red flag messaging for both fire management and the public. Again, that does focus on red flag warnings, but the spot forecasts are supplemental to the red flag program. We do issue much more spot forecasts than warnings, and they do serve as the backbone during critical fire weather situations of on-site forecasts where an incident meteorologist is not present. So I think this project and the spot forecast verification concept fits quite nicely into these validated requirement categories.
And hello, I'm Robin Heffernan. I'm the National Fire Weather Science and Dissemination Meteorologist. I focus mainly on training as well as technology and research and new science transfer. So very complementary to this effort that you're seeing today and other efforts that come out of the RISA program and Joint Fire Science as well. I'm here just to listen in and answer some questions if applicable.
Great, thank you so much, Heath and Robin. It's now my pleasure to introduce today's speakers. Dr. Tamara Wall is co-principal investigator of the CNAP RISA in Reno, Nevada. She's also the deputy director of the Western Regional Climate Center and a researcher in the program for climate, ecosystem, and fire applications. She's involved in several ongoing and planned projects related to integrating social science research into the production of climate knowledge and services at CNAP and the WRCC. Dr. Nick Nosler is a research scientist at the NOAA Storm Prediction Center in Norman, Oklahoma, where he conducts research in applied meteorology and climatology with an emphasis on wildland fire and thunderstorms. His research focuses on providing improved decision support information and tools for weather and wildland fire communities. And Alex Hoon is an incident meteorologist for the National Weather Service in Reno, Nevada. His passions are fire weather, the impact of weather events on causing extreme fire behavior, and providing on-site decision support to fire leadership and personnel. Alex has been an incident meteorologist for 8 years, deploying to numerous large wildfires across the western states, including most recently the 2017 Lilac Fire in San Diego County. And he serves as the fire weather program manager for the Eastern Sierra, Lake Tahoe, and Western Nevada region. So welcome to you all, and I will turn it over to you, Tamara.
All right, thank you, Kat. Good morning or good afternoon, all, depending on what time zone you're in. Thanks for joining us today. So just a little bit of background about the wildfire problem. As Alex pointed out to me earlier this spring, last year we spent 72 days at the highest readiness level, PL5. And current estimates suggest that 44 million homes are at risk to wildfire. It is extremely unlikely that this problem will get any better anytime soon. And there are some really strong drivers, both climate, policy, and cultural, that are going to drive it, I think, to expand. First is the baby boomer cohort, which is the largest cohort, population cohort in the world, actually, and in the United States, is now entering retirement age. Most people, when they retire, have at least 2 moves, referred to as the young old age move and the old age move. And the young old age move is often the moves that people make first. And it is often, I guess there's some real uncertainties about where that baby boomer cohort is going to move. But current trends suggest that popular destinations often include areas that are within the wildland-urban interface. The second trend I think will continue to drive more homes being at risk is simply expansion in Western United States. Looking out my window here in Reno, much of the land base is actually owned by the federal government. There's actually relatively little private land in the state of Nevada. But what is here is getting built out. And so more and more homes are getting built in areas that are wildfire risk as our footprint in and around our urban areas continues to spread. On top of that, we had suppression practices throughout much of the 20th century that have led to fuel loading. And then we also have had climatic and weather events that have led to increasing warm temperatures, lower amounts of snow and more as rain, which also changes fuel dynamics, and warmer winters also causing more beetle and bug outbreaks, which cause mortality in timber as well. And in the Sierras, we have extensive tree mortality due to the prolonged drought we had over the past 7 years. Some of the manifestations of costs. 2017 was just a terrifying year in California for wildfire. The Northern California fires, the current estimate is 11.8 billion. It has profound implications for our energy grid and the safety of that grid. We had 46 fatalities between the Northern and the Southern California fires. Also post the Southern California fires were the landslide debris flows that were related to those wildfires and the costs associated with that, as well as the cost in human life. We have profound air quality issues because of these fires. And overall, 2017 was the most costliest fire season on record. Just to give you a broad overview and a little bit of perspective on fire weather forecasting, Alex is going to provide a little bit of kind of what IMETs do in terms of fire weather, and then we'll focus in on spot weather forecasts and the research that Nick and I did over the past several years on spot weather forecast accuracy.
Cool, thanks Tamara. So yeah, I'm Alex and I'm a fire weather forecaster in Reno, Alex Hoon, and this is basically what we do as fire weather forecasters. We're providing public and wildland firefighter safety. That's our #1 priority. As forecasters, we're trying to help them to make better decisions when they're actually planning to set their daily priorities, whether they have ongoing wildfires or not. We're issuing daily fire weather planning forecasts for all of our participating fire agencies, and that goes for local, state, and federal fire agencies, including the Forest Service, the BLM, Bureau of Indian Affairs, and as well as National Park Service, and also for the state entities such as CAL FIRE or Nevada Department of Forestry, etc. So there's a lot of fire personnel that are using our forecast to basically plan their operations for the current day and the days upcoming in order to staff up for critical fire conditions. Those critical fire conditions are headlined by red flag warnings and fire weather watches ahead of those critical conditions. So that's how that they can staff up in preparation for these critical weather events that increase the fire danger. Now, our role as forecasters actually doing spot weather forecasts is a little bit different because it's not so much in planning for say for personnel staffing. This is spot weather forecasts are individual forecasts for a specific incident, whether that is a wildfire incident or for a prescribed burn. And a prescribed burn, just for for your knowledge, in case anybody doesn't know, it's just basically they're putting fire on the ground in an intentional manner to burn the understory of a forest or burning the understory of the landscape in order that later on, if there is a wildfire later on during the summer, the burn intensity will not be as much, and it's actually been shown to protect communities from wildfires. It's actually a very useful tool by land management agencies. And so we provide the weather forecast for them so that they can burn during the proper conditions. So these spot weather forecasts, we across the country, we produce over 100 during the study. I believe it was 4 years of spot weather forecasts, and there was up to 25,000 each year across the country. So there was, and actually statistically, as far as the spot weather forecasts over the last several years, the number just continues to go up because the service is being used even more and more across the country. So this is just an example of our spot weather forecast page. It's these spot weather forecasts are local scale forecast requested by the emergency personnel or fire personnel, and not only for fires, but also it could be civil emergencies, it could be search and rescue, hazmat situations where let's say a train derails and has a bunch of hazardous materials. They need to know what the wind direction is, how long the winds are going to be blowing, you know, in order to run their dispersion models. We also can run dispersion models as well from the National Weather Service and give them information on as far as like dispersion from hazardous chemicals. And nationwide, these spot weather forecasts are actually issued twice as often for prescribed burns as they are for wildfire. So in the majority of our spot weather forecasts that we issue across the country are for prescribed burns.
Thanks, Alex. So what we're going to present today is a case study of where research from the OAR branch of NOAA directly links to operations, the National Weather Service, and weather information for end users. So this is it's a complex research space. This project integrated both physical and social science research. And we also worked with several fire management agencies on this project. You know, besides the National Weather Service, we also worked with the National Wildfire Coordinating Group, Fire Danger and Fire Behavior Subcommittees. You know, we interviewed firefighters from numerous agencies, including BLM, U.S. Forest Service, state agencies, local agencies, as well as tribal. And so it really was a very broad effort to bring this research together. The research was really driven by management concerns. The original funding came through the Joint Fire Sciences Program, which is both DOI and USDA, and then also some additional funding from RISA, particularly to fund the social science component. The goal was really to inform ways to enhance the accuracy of spot forecasts. There were some concerns over both the accuracy over the physical variables, but there were also concerns over how firefighters perceive the accuracy of spot forecasts. And so we wanted to look at all of these and really get a feel for what both of these components were in terms of how, were they accurate or not? You know, were they physically accurate, and also were firefighters' perceptions accurate? So it was really trying to look at all sides of the picture. And Nick, if you want to go ahead and jump in. We're going to start with the physical science component of this project and then move into the social science component, and then wrap up with a set of recommendations and future research. So Nick?
Thank you, Tamara. My name is Nick Nosler. I recently accepted position as a mesoscale assistant fire weather forecaster at the Storm Prediction Center, but I did most of this work as a graduate student under Tim Brown at the University of Nevada, Reno, and at the Desert Research Institute. As Tamara mentioned, it was a joint fire science program funding, at least for my part, and my colleague, or I should say my counterpart at the University of Utah, Matt Lammers, who contributed significantly to the research. He handled the verification of the surface elements of spot weather forecasts, and I kind of handled the upper air elements of the fire weather forecasting. So we verified surface temperature, surface RH, surface winds, mixing height, transport winds, and Haynes index from the spot weather forecasts. As Alex showed in that one figure, over 100,000 spot weather forecasts that we looked at over just over a 4-year period, almost 4.5-year period. And then the one thing that you should always ask yourself when you're doing something, and especially for research, is why are we doing this? Tamara touched on it a little bit. You know, the need for addressing, you know, what should the accuracy requirements be? How can we improve the accuracy, or how we're communicating these spot weather forecasts? And then just the basic verification statistics for the elements that are forecasted in the spot weather forecasts, because that doesn't exist in terms of any objective or consistent manner currently for the National Weather Service, or at least at the point when we were looking at these spot weather forecasts. Slide. So a little bit more background in case you guys aren't as familiar. We don't want to over jargon you, so to speak. Spot forecasts are used to kind of make go, no-go decisions for prescribed burns. Many times when you're intentionally setting fire, you have to have certain weather and fuels conditions, and these spot forecasts will help you make an informed decision, whether or not to actually light the fire. And then also on wildfires, if there's not an IMET currently on that fire, they will use spot forecasts to help them make strategic and tactical decisions on ongoing wildfires. Now, the Haynes Index, one of the components that we're verifying, is used to measure the potential for wildfire growth, especially plume-dominated fires, and it looks at atmospheric instability and dryness. Mixing height has the definitions kind of vary a little bit, but it's essentially the vertical distance from the surface to the top of the boundary or mixing layer. And then transport winds are kind of based off the mixing height, which is essentially the mean or general wind speed and direction that transports particulates, or in this case, smoke. So you kind of need to know the height of the boundary layer, aka the mixing height, and then you'll be able to calculate your transport wind speeds. Slide. So the general objectives that Matt Lammers and I had was kind of facilitate the transfer of research to operations, especially with the methodologies to verify these spot forecasts. Like, how can we do this in a consistent and objective manner? And then Matt did a really good job and actually developed a website and some examples of web tools on how you can transition what we do in terms of the verification of the spot weather forecasts and where they're issued, and be able to visually see those and be able to query them, that the National Weather Service performance grants could also maybe incorporate or at least utilize. And then one of the main things, like we discussed, is how much more skill and improvement is added to the available forecast field, such as, we have model output. Can we just send that to the fire managers or emergency managers, or is the forecaster over the loop actually providing some inherent increase of skill or accuracy? So more specifically, we're verifying forecasts against observations. These are NWS surface observations, RAWs, remote automated weather stations, and atmospheric soundings. And then for the surface elements, wind speed, temperature, and RH, use the National Digital Forecast Database, the NDFD, and the real-time mesoscale analysis, RTMA, output to compare the forecasts to those as well. And then one of the main issues that we had is because of the somewhat non-standardization of spot weather forecasts and how people forecast, and even across the country on how different forecast offices issue their spot weather forecasts, there's kind of a natural language problem in terms of, are we capturing what the forecaster was trying to convey in their forecast? Many times they would have multiple ranges of values for one day, for one spot weather forecast, for temperature, or for wind speed, or for RH. And our goal is to, okay, which range should we pick to verify against, and then do that on a consistent manner across, thousands, if not tens of thousands of spot weather forecasts. So we were fairly rigorous in deciding what forecast to use, because of they needed to be within 50 kilometers of a surface weather station or an atmospheric sounding location, and then within 333 meters of elevation within those same spot forecast locations compared to the surface observations. My part, using the atmospheric soundings, I used the 0Z soundings to calculate mixing height, which can be calculated a number of ways. I calculated using it the Holsworth, Stoll, and Richardson number methods. And then those methods I also used to then calculate the transport wind speed for each one of those methods. And then the Haynes Index, which is calculated differently whether or not you're at low elevations, mid elevations, or high elevations. So we went through all that and looked at, tens of thousands of spot forecasts. A lot of mine were thinned out because there's a lot less atmospheric sounding locations and there are surface observations. But having said all that, the statistics indicated that we are adding, or excuse me, the forecasters are adding value above the NDFD gridded values, do a better job for temperature than we do for relative humidity and wind speed, but we are adding more value. We are better than just what would the raw forecast output would be to give to the fire managers. For my part, we did much better at forecasting Haynes index and transport winds rather than mixing height. The mixing height was actually very poor, which was a little bit of a conundrum because transport winds are a little bit based off how high the mixing height is. But the mixing height, sometimes the errors were larger than the actual mean forecast mixing height. So you had mean absolute errors that were larger than the mean forecast mixing height, and that was across thousands of forecasts that we examined. The one thing that was really interesting is that the type and specificity of the forecast was as or more important than geographical location. So in terms of biases, I didn't see that we saw like, southeastern United States or Florida had better spot forecasts than Washington or Oregon, but how the WFOs issued those spot weather forecasts and what ranges they give and how many ranges they provided seemed to drive the accuracy or perceived accuracy as we calculated or determined it in the spot weather forecasts.
Alex, do you want to add anything to that?
Yeah, so just to mention, one of the things with spot weather forecast, and I think this goes to part of the research that's being done, it's from Nick and his colleague there. So in the West, we have a lot of microclimates, very, very small microclimates out here in the West, and that's typically where the prescribed burns are being done in small canyons within a larger mountain range, and very small microclimate, which it's very hard to quantify that with the local weather stations around. So that is part of this as well. But yeah, definitely the geographic location has a lot to do with the forecasting for spot weather forecasts. I mean, we're actually trying to put in that detail for that specific location.
All right, thank you, Nick. And then just go ahead.
No, that was it. I was just saying thank you, Tamara.
And then moving on to the second part of the project that I was responsible for. So we had to make some decisions about what we had the resources to do. And so I focused specifically on prescribed fire use, not wildfire use for spots. I did mostly focus groups with approximately 90 students across several different geographies at S490 courses. These are advanced fire weather courses that that firefighters have to take if they want to become what's called a burn boss. So if they want to kind of move up the ranks from a ground level position and become more of a foreman that can actually manage a prescribed fire, S490 is required. So all of the people that I interviewed had extensive experience with prescribed fire across both California, the Intermountain West, and the Southeast. And then I did that original set of interviews and then presented the preliminary findings to the Fire Danger, the National Wildfire Coordinating Group Fire Danger Subcommittee. And they suggested that I also interview National Weather Service forecasters, IMETs, in these areas as well, which turned out to be a great suggestion. That was not part of the original research process, but because we often in RISA work in a very co-produced manner with the potential end users of our information, I was able to get this perspective as well, which turned out to be a very interesting one. So here's a quote from one of the participants, a burn boss. And one of the themes that came up over and over again in this research was that these parameters are difficult to forecast, but even very, very small differences can make a huge difference. And that is because in prescribed fire, every prescribed fire has a burn prescription plan. And within that plan, there are variables such as wind speed, RH, and other conditions, fuel, flammability, that have to be met if the burn is going to move ahead. So if a spot forecast comes back and the forecasted wind speed is outside of that prescription plan, then the spot essentially becomes a go, no-go decision tool, as Nick mentioned earlier. And so accuracy is often very, very important, particularly in areas of the West. Burn windows, areas of periods of time where prescribed fire bosses can actually do burning and do those fuel treatments to try and reduce fuel loading, for public and wildland firefighter safety, are often very narrow. So the accuracy really does matter in a very, very serious way with real on-the-ground consequences.
So one of the things as an incident meteorologist, when we're actually on site and talking with the firefighters face to face, one of the things that we see, like what Tamara was saying, is that the accuracy is super important for their operations. And wind speed and wind direction is like one of it's at the top of the list, because it drives where the fire is going to move and how fast. So we don't have that luxury of having face-to-face interaction with our customers when we're putting out a spot weather forecast. So basically, here's our spot weather forecast page here. You can see it on your screen, and it really is our most important tool for communication between the National Weather Service forecasters and the burn bosses who are trying to determine whether or not today is a good burn day, go, no go, or potentially if they need to shut down operations earlier than anticipated. So if you notice, there's a little box there. It's called a remarks box, and that remarks box really is I don't know, we call it a remarks and concerns box, because we tell our partners, our fire partners, that whatever concerns that you may have, please put it into this remark box. Like, we have concerns, for example, we have a very good relationship with some of our burn bosses here in the Lake Tahoe and Truckee areas. And so we encourage them to say, okay, what are your concerns here? Like your spot weather forecast, you're obviously burning near a town. What are your concerns? And their concerns are like, we don't want any type of east winds at night. If we have any type of east winds at night, it's going to funnel all the smoke down into the town, and then that will create a hazardous air quality situation for the town of Truckee. So they would put that into the remarks box. That would be their concern for the day, and that tells the weather forecaster sitting here at the office, okay, I need to be especially concerned if I see any wind direction from the east. I need to make sure that I'm giving these guys a heads up so that they decide not to burn on that day. So that's just one example.
Okay. And so that leads into one of the main themes that came out of this research was communication, and how that communication and how it happens or doesn't happen, both on a burn day, before a burn day, and after a burn day, perceptions of accuracy. So what we noted in this was that the firefighters I talked to really tended to find forecasters that they communicated well with and respected. They are very good at sussing those forecasters out, I think, which are often IMETs, getting their phone number, and sometimes calling them directly or asking for info when they know a certain IMET or forecaster is on duty. So in that sense, that they will really figure out if somebody has a really good relationship with Alex, they might be like, so when are you on the desk? And so that communication is just not a problem that's easily solved. So the burn bosses are concerned sometimes if they're talking to forecasters that they have a sense they don't have the knowledge about fire and fire weather that they are really looking for. It's a human factor that extends way beyond just the fire community. I mean, I think this is something that National Weather Service forecasters deal with all the time, particularly when they're dealing with sophisticated user groups, whether that's transportation departments, emergency managers, or firefighters.
Absolutely. And one more comment, this is the direction that our agency is moving, is trying to improve that communication with the end user. We have these super users, or another word is deep. We've been calling it deep core partners. These are the guys that are using our weather forecasts for a lot more higher end decisions than whether or not they're going to go for a picnic or go out to the beach, or if they need an umbrella for the day. This is way more. This is actually potential impacts for life and property, and so in order for us to better create a forecast for them, we have to understand their job even more. And I think that in this instance, for spot weather forecasts, IMETs know, because they've been out in the field, they know what the firefighters are looking for, they know what their job entails, and the big stress for us as an agency is getting all of our forecasters to understand what our end users are and how they are using our forecasts.
And when that goes awry, it really can go awry and have very real-world consequences. Alex, you were telling me a little bit about what the Reno Forecast Office does here.
Yeah, so one of the things that we do locally, we set up we have our partnerships with our local fire partners set up well in advance. We have pre-season meetings ahead of the fire season, ahead of the prescribed burn season. We talk with them. They send us their information, whether or not, what their prescriptions are going to be, what their projects are planned for the spring. We have post-season meetings in the fall, so that after the fire season begins to wrap up, they actually go into another prescribed burn season during the fall season. We have another meeting with them, and so we're constantly making these, improving our relationship with them, so that we understand what their needs are, and then they also understand what our needs are, as when we're putting together the forecast. What kind of information do we need to give them a better product? And another thing that we've been trying to do is actually send out forecasters. We send out forecasters as much as possible to the prescribed burns. So you actually have a forecaster who's in the office going out into the field, into the mud, into the dirt, and actually going out with the firefighters and watching, like, okay, what are they using the forecast for? How is the forecast impacting their decision making out in the field? And that perspective is actually incredibly valuable.
Yeah, and I think it really builds that mutual understanding of work environments and context, both from the forecaster's needs as well as the end user's needs. One of the challenges with this communication, though, is that while Alex has a very good relationship with his burn bosses up in the Reno Lake Tahoe area, firefighters move around. They move around a lot, and so those relationships have to be built and rebuilt, renewed, and created, over and over again. Sometimes within a single fire season. Depending on the preparedness level and what's going on the ground, lots of firefighters can be moved into an area, and suddenly Alex and his colleagues at the Reno Forecast Office may be dealing with a whole new set of firefighters.
And the other way around as well, where we have multiple forecasters working the desk, doing the spot weather forecast. So on any given day, the firefighters who are requesting the spot weather forecast can get several different fire fire weather forecasters on during a period of several days. So one of the things about this, and this is very hard, is actually training weather forecasters to have some type of almost a more standardized way of producing these spot weather forecasts as well, which is kind of this is definitely a stumbling block for us. You know, just think about your doctor, right? If you go to your doctor and you have something going on and you ask your doctor, hey, what do you think it is? You know, he's going to make an educated guess as to what's going on in your body. But that's why you go, you know, a second doctor, a third doctor may or may not have the same opinion. And so, you know, same type of thing goes with fire weather forecasters, is that, you know, you ask a couple of different forecasters and they may have slightly different takes on what the weather is going to be. So this is, you know, part of the human factor of weather forecasting.
And Alice, didn't you tell me that you're going to embed forecasters in a fire dispatch center?
Yeah. So this is actually a very interesting take on how we're trying to get over this stumbling block. We're actually going to be sending some forecasters down to our local dispatch center this summer in order that communication between the firefighters in the field. The firefighters have to talk to the dispatch center that is located in a centralized location, in our case in Minden, Nevada, and then improving that communication between the dispatch center and the local weather office. So in order to improve that, we're actually going to embed a forecaster during critical fire weather days, so that we can improve that communication.
And then one of the other from the forecasting side is that spot forecasts are very resource intensive. And for offices like Reno, Salt Lake, southeastern Florida, they often have 25 or more spot forecasts a day on top of their regular workload. And so one of the real challenges from the forecasting side, and I think as we saw also in that previous quote about sudden wind switches, is the forecaster's ability to stay on top of those type of changes, particularly in the West where we have so many microclimates, can be really challenging.
Right.
And this is more of I think along the lines of a structural challenge for the National Weather Service.
And again, this goes along with that whole communication between the field and the local weather office. If the firefighters in the field are seeing something that is not going right, if the wind direction is different, the wind speeds are different than what was expected, then it's also on them that they need to give us a call and say, hey, Reno Weather Office, hey, Alex, I'm seeing conditions that are much different than what are in the forecast. Can you give me an update, or can you send me another spot weather forecaster with an update? And that back and forth communication is extremely important for firefighter public safety.
We're hoping in the future that technology will help. Certainly in the West, the ability for firefighters to utilize cell phones in the field has changed dramatically and made that type of up-to-date communication much more realistic. The other part of this are dispatch centers, and the relationship between forecasters and the dispatch center. Some of my research suggested that that extra layer of communication could be problematic, but it also is really important that it gets into the formal log of communication. And I wanted to ask, either Nick worked as a dispatcher in the summers while he was doing his PhD work, and I wondered, Nick, if you had any comments on that, or Alex, if you did.
Yeah, Tamara, I'm excited to hear that Alex, or at least NWS Reno, is embedding forecasters into dispatch center, I know when I worked in Grand Junction for multiple summers, the field took full advantage of having a meteorologist in the dispatch center, and they would always go through the proper channels and interact with the local WFO. But having that rapport with me and someone they could just easily call up when things were looking different, or just to kind of affirm the forecast, they really took that to heart and used that a lot. And when dispatch gets busy and when you have a lot of fires, you have multiple prescribed fires going, it becomes a choke point. And so if you are trying to be the go-between between the field and the forecast office, that tends to fall down the what's the word I'm looking for? It's not as important, and it goes down the list of priorities unless it's a serious weather situation. But a lot of it, you're trying to get firefighters the correct gear and supplies and make sure everyone's in the right place and that you know where everyone is. And so it can be a little bit chaotic when you get into those situations.
Thanks, Nick. And then the next area I just wanted to talk briefly about, we may need to go a little bit more quickly over some of these, was really the questions of accuracy. Perceptions of accuracy often really revolved around forecast confidence and uncertainty, and how to communicate that uncertainty through an object like the spot weather forecast page. This really got into questions about how the spot weather forecasts are used, for go, no-go decision points, and also the role of deterministic versus probabilistic forecasts, and then how to provide ranges and communicating these in a spot as well. There's some real challenges with this, and I think it'll show up in some future quotes as well, but it's really comes down to a forecaster may have varying levels of confidence about that forecast, and trying to communicate that confidence or lack of confidence can be really challenging. And so what the research with this group of people seemed to show, I think oftentimes those perceptions of inaccuracy are really tied to confidence, and also uncertainty in the forecast itself.
So this is another way that the human-to-human interaction is so valuable, because we produce a spot weather forecast, and this spot weather forecast gets sent out over the interwebs, and then they pick it up and then print it out, right? Well, those numbers, even though they're intended to be used for their go no-go decisions, they're typically deterministic. The numbers are kind of, it's a number range. But the thing is, like, when you pick up the phone and when you call the guy or the gal who is requesting the spot weather forecast, you pick up that phone and you give them a quick little briefing. You say, hey, so just wanted to run through the forecast really quick with you. This is what we're seeing. Temperatures are expected to get up to 70 degrees. But just so you know, if that inversion breaks a little bit earlier, those temperatures could get up to about 80 degrees or more, which would also affect your winds and your minimum humidity. But there's a lower chance of that happening today, only about a 20% chance of that happening. So you're able to kind of relay a little bit more information and uncertainty, giving them a little bit more probabilistic forecast through a briefing.
But if you have 25 spots,
that's
really
a
hard.
Workload issue, yeah, for sure.
Yeah. And I think this quote just kind of, again, follows up with what we've been talking about for the last few minutes. And then I want to make sure I leave some times for questions, so I'm going to go through these kind of quickly. And one of the other, kind of the other side of the coin is that forecasters really need information back, and they don't get it.
Yes,
All the
that's part.
Yeah.
that's been part of that's always a tough instance, because when the firefighters are out in the field, they're doing 1,000 different things managing this fire, and weather is just one part of it, right? But trying to get these guys and gals out in the field to give weather observations back, give us feedback. Was the forecast, was it good? Was it bad? How can it be improved for the next day? Because usually these spot weather forecasts are issued multiple days in a row. But getting that feedback back allows us to improve our weather forecast.
Yeah, but there's no good mechanisms currently for. There's no incentive.
There's no incentive for it.
Yeah.
But it's just more of educating them, and this is part of the preseason education and post-season education. Hey guys, don't forget, you need to send us feedback. If you want a better forecast, the more information you give us, the better your forecast is going to be.
Yeah. And so in summary, kind of the three themes that really came out of this portion of the project were that relationships and mutual awareness of working conditions are really important. There's challenges in communication, not just during the day of a burn, but how important that pre-season, pre-burn time is, as well as after. And then the challenges around communicating confidence and uncertainty in the forecast. We came up with a list of recommendations. Heath and Robin can talk more to it, but some of these are being worked on right now. Others, are still kind of in the works. And let's see, I'm gonna just go ahead and just move through this. And then to wrap up, Wildfire really is a coalition of the willing and the able in trying to manage fuel conditions, manage both prescribed fire and wildfire in a way that has resource benefits, but also protects human safety and firefighter safety. And I think one of the really great things about this project was that through CNAP and the RISA program, we became more than just, this research really demonstrates that we're more than just a convener of groups, but we, through, Nick doing his PhD work, we actively train and support and mentor researchers in the skills necessary to do this type of research. I was just wrapping up my postdoc when I started this project, and couldn't have done it without the mentorship of Tim Brown and Kelly Redmond and some of my colleagues at CLEMIS, the Arizona RISA program. And that RISA is also really good at doing these kind of social and physical science projects, that involve end users. We try very hard to work across different aspects of NOAA, both operations as well as research. And have a really direct societal impact. And really understanding how our research can be used by operations and the fire management community was really a driving factor in this research. And then just a heads up, through some pilot funding through CNAP, RISA, and the National Integrated Drought Information System, along with Robin and Heath and Alex, and hopefully Nick, if he is able to, in his new position. We are going to be taking a look at Red Flag Watches and Warnings project, which is just kicking off right now. I've started doing the preliminary research, and we will be holding kind of an organizational workshop to guide the project questions May 8th in Boise, Idaho. And I will leave it at there with all of our contact information, and we even have 6 minutes for questions. So considering what we covered, I think we did good, Alex and Nick.
Thank you very much. Thanks for having us.
Thank you all. That was really wonderful. And I was so struck by one of the quotes that said, it's not that the information isn't correct. It's not that it's not accurate. It's just that there's that disconnect sometimes between the information and understanding how it's being used. And I think that this really highlights the importance of those trusted networks and understanding all of the different factors that go into making making the decisions, the decision context that this information is being used in. So I'll just remind you that we've got some time for questions. Feel free to enter your questions into the questions tab, or I've also, I'll be monitoring the chat box too, if that's easier. We do have a couple of questions right off the bat. The first is, can you talk a little bit more about wildfire and why it might be a concern for the energy grid? There was a comment really early in the presentation about the concern between those two, the wildfire and energy.
The concern, so this stems particularly from the California context, but in 2007, there were several major wildfires in Southern California, in the San Diego County area, and those fires were started by power lines that touched together and arced and started those fires during a Santa Ana wind event. And San Diego Gas and Electric was held liable. And although the investigation is ongoing, there is some concern that power lines might have also been the start of, the ignition source for the fires in Northern California in 2017. So how utilities respond to this risk can be a real challenge, and it can be very expensive. San Diego Gas and Electric, don't have time to go into detail on it here, but they have done a remarkable job in responding to that risk, and I think in a way that's a model for utility companies that may be at risk from these type of weather-related events.
Great, thanks, Tamara. I do have a question here for Nick. In your verification on mixing heights, did you notice some sort of persistent bias? For example, was the forecast generally higher or lower than reality, or were there trends in what you saw in your observations?
Overall, not like really severe trends. It was more just large errors. Sometimes, like Alex mentioned it about, his example with the inversion, sometimes that inversion holds and sometimes it doesn't. To be honest, I can dig back into the tables to see how strong the biases were, but what I remember was the mean or median absolute errors were quite large, but the mean errors weren't that bad, which kind of showed you there was some bias. And I'll be honest, I can't remember right off the top of my head which way, but it was just the errors overall. It didn't seem to be a very strong, consistent bias to over forecasting or under forecasting. But both mine and Matt Lammer's papers were published in the NWA Journal of Operational Meteorology, and you'll be able to find all the statistics in there as well. And I'll be happy to email anyone if they want to follow up.
Yes, and the social science part of this project was published in Weather Climate Society, and it's open access. So if anybody would like that citation or like a copy, they can just email me.
Great, thank you. I have a question for Alex. I'm interested to hear more about the remarks box that you had talked about earlier. I know you referred to it as the remarks and concerns box, and I'm wondering if that field, since it is it's kind of an open-ended data entry point, I'm wondering if you can speak to the consistency of how it's used across the country, whether it's a remarks and concerns box always, or if that's sort of specific to your particular region.
Well, so I think it depends from office to office. I can't speak necessarily for the other offices how they're using it with their partners, but I know that just locally we've really stressed to them to use that box as a communication tool, that they can have their concerns heard, whether it's their specific wind directions or their prescribed burn, their prescription, their humidity cannot be less than 20%, or their wind speeds, if their wind speeds are greater than 20 miles an hour, then they can't burn. Being able to communicate those specific boundaries it's so critical for us as weather forecasters to understand what are they looking for? What is their intent for using this weather forecast? What are their specific boundaries that they're looking for? So that is something that I think that we can work on as an agency, for sure.
Great, thanks, Alex. So we're right at the hour, and I'm not seeing any other questions in the question or the chat box. So unless I see little bubbles indicating typing, I think we will close it here. Thank you again to all of our speakers. And just as a reminder that we'll send out the recording of the webinar when we've got it posted up on our website. So with that, I will say good afternoon and thanks so much for joining.
Thank you.
Thank you.
Thank you.